All right, well, it's 2 minutes after, so I'm going to get started. Hello and welcome to our fifth installment of the ABE Teacher Roundtable series. I'm Amy Ulyurk from the program office. In case you didn't hear, Jess is here. She's just having technical difficulties and she will be questioning our panelists, but I'm just here to give the introduction. So these sessions were originally designed for the ABE Master Teacher Fellows, and we've opened these up to the ABE teacher community as a chance for all of you to learn from one another about topics of specific interest to science and biotechnology teachers. We hope you find this series valuable, and feel free to tag us on social media if you want to share your thoughts using the tag @ABE Program Office. This roundtable will be recorded and posted on our website, and registered participants will receive the PowerPoint and any materials along with a link to the recording. And we will have time for some audience questions at the end, so please put your questions in the chat at any time during the discussion. We'll be sure to watch for those and ask you to ask the panelists your questions at the end. So we have a very exciting panel. Everyone here on our panel is an ABE teacher, and our ABE teacher community is incredibly strong with deep expertise. Our global teacher network has leaders and experts in pretty much every aspect of science education that you can imagine. So today we're honored to have with us representatives from 4 of our program sites: Los Angeles, Massachusetts, Ireland, and the Netherlands. And our panelists will share with you some of the ways that they think about and define differentiation, strategies they've used, and lessons they've learned along the way when trying to make ABE accessible for all students. Also, examples of specific activities that they have used themselves to differentiate or extend ABE in their classroom. Now, without further ado, let me introduce our distinguished panelists. Dr. Erlette Reyes of ABE Greater Los Angeles is a lifelong educator and coordinator at Daniel Webster Middle School and STEAM Magnet. She is involved in promoting and facilitating ABE programming at her site, as well as hosting a weekly session titled College and Career Corner for students. Mark Schaefer of the Netherlands teaches biology at Kandinsky College and aims to infect his students with a passion for molecular biology, his words, not mine, and life sciences through master classes and projects. He's recently begun investigating how to introduce virtual reality into the curriculum. Mary Liu of ABE Massachusetts teaches honors biology, AP biology, and biotechnology at a public high school. She is also the teacher in residence at Lab Exchange. She is interested in integrating opportunities to build science skills in person and with digital supports. And last but not least, Dr. Declan Cathcart of ABE Ireland is a biology teacher at Temple Carrick School. He's also a part-time lecturer at the School of Education and the School of Mathematics and Statistics at University College Dublin. He's been collaborating on materials and resources with ABE Ireland since 2015. So thank you all so much for being with us today. And Jess, I'll hand it over to you to ask our first question.
Thank you so much, Amy. And I have to just express my debt of gratitude for Amy for stepping in at the last minute and just handling both the technology and the introduction so beautifully. And I also want to acknowledge this is a reunion of sorts for our first cohort of Master Teacher Fellows. We have 3 of our fellows from last year who are joining us on the panel today. And as we said before we started this roundtable, we're really, we want Mary to just apply so that she can join the ranks. So we're so happy to have all of our panelists with us. It's just really an honor to have them with us today. And so without taking too much time, I just want to start by asking each of you to say a little bit more about your role at your school, what kind of role you play in addition to being a teacher, and also how do you define differentiation? That's really the the purpose and the focus of this roundtable, but differentiation can mean a lot of different things to a lot of different people. So maybe we can start with you, Dr. Reyes, and ask you to just think a little bit about, what do you do and what does differentiation mean for you?
Thank you so much, Jessica. Good afternoon, everyone. My name is Dr. Reyes, and I am currently the magnet coordinator at Crenshaw High School. So sorry, guys, my ABE team, I didn't tell you guys about that change. So I moved over to Crenshaw maybe about 6 months ago, I'm gonna say, from Daniel Webster Middle School. For me, differentiation is about access and exposure for the students that I work with. I deal with primarily a low socioeconomic population. And so I seek out ways to provide my students with exposure to content and careers that might not be readily accessible to them based on their socioeconomic status. This means that I may need to move slower in some places. Normally at the beginning, as I'm sure all ABE teachers will agree, that's kind of when we need to go the slowest. But I think for me, I move a little bit slower than most in those beginning phases. Use a variety of resources. So that could be video, images, and of course the hands-on experience. Nothing beats that to support students. Largely though, for my students, their level of engagement or willingness for them to go along with me on this biotechnology journey is based on delivery and reassuring students that we are in a safe space, right? So the students kind of recognize that the content, the equipment, the information is something that's above their heads, that they have not experienced before. So feeling safe to know that it's okay to make mistakes and that we are there to support them in developing the content knowledge and the skills seems to really work in supporting the students that I work with. I had a student in January, because I was able to do the ABE labs here hands-on at my site in January. Some kids I could feel the resistance, didn't want to touch the equipment, kind of probably afraid they were going to break it. And so there were times where I literally had to put my hands on theirs and say, we're going to hold it like this, and it's okay. And this is the space for us to make mistakes before we get to that gel box. And I'm referring to ABE Lab 1.1, which does a great job of giving them that micropipette practice. To this end, the PBL lessons, that's the kitten paternity, the dog drool, and I'll talk a little bit about the viral variants that I developed in my ABE time. Those are most helpful for students that have not had any exposure to biotechnology, because it presents almost like a game, right? When you give them the PBL mystery, it gives the relevance to the material that we're going to cover. So I really think that my approach really revolves around looking at my students and understanding what levels of access they don't have, and differentiating to make sure that I'm providing a realistic exposure expectations for our students in this area. Thank you, guys.
Thanks. I love that, Dr. Reyes. And it's making me think your mention of a safe space for students to be able to try things out, and this idea of inquiry also being a way for all students. It's kind of I'm giving a shout out to our Italian team, many of whom are with us today, because they were just discussing those two things when they did their inquiry-based science education roundtable last month. So it makes a lot of sense in hearing a lot of connections. I wonder if we might be able to hear from you, Mary, about your role and how you've thought about differentiation in the classroom.
Sure. My name's Mary Lou, and I'm a science teacher here at a public high school in Massachusetts. I teach a variety of levels, from introductory biology to AP biology to biotech, which is an optional elective for students. I think about differentiation as really a way to support my students to meet those learning goals, whether I'm changing how students access content, whether I'm supporting them in providing scaffolding, and like Dr. Reyes mentioned, also varying the pace, right? Providing different explanations and opportunities for them to explore really helps them feel confident and comfortable in tackling this challenge. It's super important because my classes are very diverse, both in terms of learning styles and learning abilities. They're also diverse in terms of background and grade level. Our biotech class can have students who haven't taken biology or are concurrently taking biology to students who have also taken AP biology. So part of that challenge is bridging the gap so that everyone can approach this scientific task with an open mind and sort of don't close doors, but instead think of them as opportunities. So for me, both adjusting my practice and instruction, but also adjusting the learning environment, maybe providing extra encouragement or attention or flexible grouping to help them work together to accomplish this goal. I think one of the best parts about the ABE program is the extended nature of it, like that it can build on itself and it really has that real world connection. So as students complete the series from lab 1 all the way to lab 6, they feel like they're really a part of something and doing real science. And it's a great opportunity to build in that support as well.
Thanks so much, Mary. And I just really appreciate sort of your emphasis here on access. And we know that students oftentimes are forming their STEM identity before high school even. So in middle school and high school, thinking about themselves in STEM. And so finding ways not to make STEM be a kind of door closing in their face, but rather a door opening. I think the way that you put that was so important. I'd like to invite Dr. Cathcart now to share a little about his role at ABE Ireland, as well as a special thank you for joining us at a late hour, his time. So a little more about your role, Declan, and how you define differentiation or think about it.
Brilliant, thanks, Jess, and it's great to be here. So thanks for inviting me. Yeah, so I teach in a state school outside of Dublin, and it's a fairly big school. It's about 1,000 students at this stage, where I'm teaching sort of 12 to 18-year-olds, and I teach all the age group, all classes at all the levels. I teach biology, teach junior science, I teach maths, and I teach a biotech module to what we call transition year, which is sort of a middle year when they're not exam focused, and it's much more sort of open-ended and flexible. So that's a great space to be able to introduce biotechnology in the way that I'd like to do it. So for me, I guess differentiation really is kind of synonymous with student-centered learning. So like I said, the really nice space that I have with my biotech students, my transition year biotech students, I like to think of it as kind of there's 3 C words that come to mind when I think about differentiation. Is that students need to be, so it's all about trying to raise, for me with my biotech crowd, it's trying to raise their confidence in various different ways. So while I want them to be sort of comfortable with and we were talking about safe spaces, I really like the fact the idea is that my biotech lab is a safe space for them, and they can work at their own pace, and they can gain ownership in what they're doing and the projects they're doing. But while it's comfortable, it's also challenging. So I really like the idea of productive struggle, right? So the course that I kind of developed, and I've been developing over the last few years, and I was able to really kind of do a deep dive into developing some new aspects or new parts to the biotech course that I teach through the Master Teacher Fellowship Program, which was a great opportunity to really, to dig in deep with some things that I kind of had in the back of my mind, I wanted to develop over the last few years, and which kind of came to fruition then last year. And I'll talk a little bit about those later on. So I'm all about inquiry-based problem solving, sort of projects in which students, I guess they learn. It's a vehicle for them to learn the fundamentals of science, of biology, of method, of laboratory skills. But actually, even more importantly for me, it's a vehicle for them to gain ownership, like I said, and also to learn the fundamentals, to use biotechnology as a way of learning fundamentals that actually often these 15, 16-year-olds that come into my biotech lab they might be able to you know, do well in an exam in biology, but really they've missed the kind of the opportunity to have, you know, to do the kind of deep learning that I think they can do in my lab. So yeah, I like to you know, I like to see peer tutoring going on. I like to see students working at their own pace. I like to see students really kind of investing and you know, getting their teeth into a problem that I set them, various problems that I set them as they go through the year.
I think what you've said is so important, especially for people who are trying to wrap their heads around defining differentiation, that it's not necessarily dumbing things down for different students. It's about that productive struggle. I love that term that you used, and thinking about how do you help students access the rigorous content? How do you help them kind of find those entry points into the harder stuff so that it is rigorous, it is robust, and it does let them do that meaningful inquiry. So I just am so appreciative of you raising that it's, you know, I think many people feel that differentiating means somehow providing less than for some students. And so appreciate you kind of making that distinction. And last, but certainly not least, Mark Schaefer from the Netherlands. Can you share a little more about your role and what you think of when you think of differentiation?
Yeah, well, lots have already been said. First of all, thanks of all that I can be here. It's really exciting. Differentiation, well, it is a very big word, and already as lots have been said and good things have been said today. Differentiation for me means, and I try to add something. Oh, first, my role. Science teacher. I'm a science teacher. I'm a biologist. And my students are, for science, are pretty young, are about 11 or 12 years old. And my school is just a normal high school, and our students, their ages go up until 17, 18, so 11 until 17, like that. My science classes are the youngest kids, and then some biology classes that have some older kids. In our science lesson, we try not to scare kids off from science, because they come here with some idea that science is extremely difficult, and they think, oh no, I'm going to high school for the first time and now I have science and it's going to be difficult. And I don't want to make it easier, but I want to make it more fun. We give them choices. They can do a research of themselves, what they like to research. So we give them a theme and they just do a research, whatever they like. And it's well, Declan already mentioned the word inquiry-based learning. That's the way that we do it. So I think that adding a choice for the kids is also an important part for differentiation, because then they can do something that they really like, and they are more focused and they're more willing to go deeper into the material and to do whatever they have to do. And in the meanwhile, they pick up some strategies to do research. They learn how to do a research, and that's something that's really valuable for them in the rest of their lives. So choice is something that I like to add. I also try to apply to lots of different learning styles from the children. Sometimes through practical, I show something, sometimes I tell something, sometimes let them read something. I try to vary it during my lessons, and it's to get most of the kids, well, to reach the most kids. Some kids, and that's already well, like kind of an introduction for my VR. Lots of kids, they have problems in visualizing whatever they read or whatever they learn, and they can not easily make a picture of it. Well, that's why I sometimes add pictures in my PowerPoints, in my presentations, but also VR is a very nice vehicle that I'm trying out, I'm pioneering with at the moment. So I think that's what I can add to everything that has already been said about differentiation. So that's yeah, my
Thank you so much, Mark. And I just love it's so infectious, because I think you bring such joy to your classroom, and you so clearly have fun doing what you're doing. And that can be a strategy, that, you know, it's not either or, that science is exciting and fun and joyful, and that you help your students kind of discover that through that kind of hands-on learning. And so it's a perfect segue, really. I know we're very excited to see some of your show and tell. So I'm going to be a little bit sneaky and combine these next two questions for our panel so that we make sure we have time for the show and tell. So I wanted to ask each of you, you are all ABE teachers, so you've all taught the ABE labs. And so are there points that you think where you have found students are particularly in need of differentiation? For example, are there specific labs or specific activities that you have found really benefit from having some adaptations or some differentiated approaches? And if so, what are those? And do you have sort of general strategies you might recommend or advice you would give to teachers when trying to take that approach? Maybe we can start with you, Declan, and we'll just change it up, kind of surprise people one at a time.
Sure. Yeah, so the group of students that come into me at 15, 16, it's a fairly broad range of abilities, and you know, like I said, it's a state school, so it's a it's a range of socioeconomic backgrounds as well, cultural backgrounds. So the broad range of ability, and this is why we're talking differentiation here. The lovely thing that I find about ABE and about my biotech module is that it really is something that students can build for themselves from the ground up. So, like I said, I've got the lots of room for maneuver. I haven't got there's no state curriculum that I've got to follow with my it's a 10-week module that I run. I see them 4 times a week. So I've got plenty of time, and they have plenty of time. So like I said before, it means that they can kind of move at their own pace. It also means that because there are no particular deadlines, it means that some will move fast, and others, some will be able to be very quick at sort of problem solving tasks that I set them. So I rely on a lot of peer tutoring in the room. So I sometimes I set that as loose groups, but usually what happens is those groups end up kind of overlapping and merging and melding, and so I'll talk a little bit about it later on, the specifics of the activities that I get them to do. But I'm talking about activities that span 2 or 3 weeks, where they've just got one particular problem to solve, and they can take it in some. Not in any direction. I should say that what I don't do is discovery learning. You can't discover your way through how to work a micropipette. That's not going to go well. So it's very much guided learning, or guided inquiry, I should say, right? So I use ABE as a lot of the ABE labs, but then I've adapted them so that I can have a sort of a run-in, a sort of a biotech 101 that I've built on, that I can run into the ABE labs with my guys.
I love that. And I just was picturing, we had this conversation with our scientific inquiry group across program sites about sort of that continuum of inquiry, and that if throwing everyone into the deep end of a pool when you've never used a pipette can lead to some tears on the part of both the students and the teachers. So I'm so glad that you made that distinction, that's not necessarily what discovery learning is, not appropriate for every aspect of biotech learning. How about for you, Dr. Reyes? Have you found any particular labs? I know you've worked with both high school and middle school populations here in the US. So are there strategies that you found really beneficial, or particular labs you would call out?
Yes. I'm gonna see if I can share my screen right here. So are you guys seeing my screen? Oh, there we go. So I've taught AP Bio for well over 10 years, probably closer to 15 years. And because of the lack of exposure that my students normally come with in biotechnology, again, I'm back to that idea of really needing to start slow. Even though my previous site was a medical magnet, and most of the students that I had were juniors who were in our hospital program that were stationed at various sites throughout the city, but still very limited exposure to what we're doing here in ABE. Now, my students that were at research sites really gravitated and connected with this because they were doing bench work at their sites. Thinking about the PBL aspect of this, I feel like it's kind of built in, that research piece, when we're looking at the AP level. And then what would happen is I would end up stuck on the abridged version. I don't think in the high school that I was at, even though it was a medical magnet, that I ever got the opportunity to do the non-abridged version with my students. And so here I feel ABE did the adaptation for me, you know, and I'm truly grateful that they took the time to kind of figure out where they could, you know, kind of shorten things, because we all know we have the equipment for about 3 weeks. And so we're trying to get, especially in an AP class, I'm trying to get to purification, but I definitely want to get to transformation before my 3 weeks are up. And so my kids not having the exposure and me having to go really slow slows me down in the curriculum. However, I'd like to note, and this is a plea that I've just been kind of throwing out there continuously, because I'm hoping that it reaches us as teachers and that it trickles higher up. So if we took the pre-AP approach to biotechnology, to our ABE labs, and we introduced it in middle school, and I saw that it works there, and whether it's the dog drool, the kitten paternity, these things tend to get the kids excited about what are we doing next, how am I going to figure out the answer to the problem that has been posed. And so if it's not set up in the middle schools, and we know it's not, I think the middle school that I worked with was the only one in the LA area. And we had one middle school in Pasadena, and I know that the teacher from that area was retiring. So you're looking at not having this level of rigor, exposure, engagement, you know, with our biotech on the earlier phases. If the middle school doesn't have it, we could also do it on a 9th grade level. Pre-AP could be a part of any curriculum because these are the concepts that are included there. So pre-AP is not so much about the content itself, but about the skills that you're building with the students. So it makes it easy to insert that biotech, because we're looking at close observation, we're looking at analysis, evidence-based writing, higher order questioning, academic conversations are all a part of the ABE curriculum already. So trying to get, you know, schools, districts to kind of make that shift. If we pose it as pre-AP, what's after the pre has to be AP. And there we can forget about the abridged version now, because my kids already have some of those beginning skills, and I don't have to go as slow in the beginning. I don't have to spend as much time with the skill level, and I can move directly into that unabridged content. I'm hoping that I hit everything. The last thing I wanted to share, it's become almost a signature for me because I am a hands-on coordinator. So I always ask for a classroom. I know it's kind of strange because they think all of us coordinators are trying to run away from the classroom. And then here I come begging for one. And normally the first thing I do with that classroom is I convert it into a magnet lab. I did that at Webster. It's the first thing that I did when I got here. It gives me a space where I, as the coordinator, can come in and do those engaging activities if I'm not seeing it in the classroom. I then rope the teachers in. I facilitate the first one. Hey, do you want to do the next one? And they're always excited to try, and then I try to, okay, Amgen training is coming up. So it's a process, it's a mind game, but it's a mind game towards better engagement, better access, better equipped teachers to deal with the rigors of science that we want to see our students fulfill. And I hope I wasn't too long-winded. Thank you.
You're not too long, because you're the reason we're here. So we want to hear your thoughts and your wisdom on this topic. And I'm hearing just this call for rigor and not sort of under assuming what our students can do. Really.
I think you got muted, Jessica.
I'm so expert with my phone, as you can tell. I was going to say this call for rigor that's really echoing what Dr. Cathcart was talking about, and that I know we're coming up on our show and tell time. So I just wanted to ask quickly, Mark or Mary, if there was anything you wanted to add here in terms of specific ABE labs or approaches that you would advise teachers to be thinking about. Mark says no, he'll pass and save his time for VR. Mary, how about for you?
I was just going to say one of the most challenging parts for students is really the approaching the molecular concepts. Like, this is a kind of a new idea for them, thinking about bonding and these plasmids, and like particularly labs 2 and 3. I know not everyone does the full sequence, but it's a lot of things they can't see. So one of the biggest strategies that I use is incorporating a lot of visual aspects and providing visual supports, whether that's through models or digitally. And I'll show you some that I use later to incorporate that. So that's all.
That's great. And actually, just making sure. Yes, I am unmuted. Mary, why don't we just keep going with you, since that makes, we'll just roll right into some of these examples that you brought with you today.
Sure. Yeah, let me go ahead and share my screen then. My digital examples are actually all hosted on LabXchange. If you're not familiar with LabXchange, it's a free platform. There's lots of ABE resources there that go along with all 6 of the labs if you want to find them, if you look for this cluster called Foundational Concepts and Techniques. But I'll show you ones that I've made and used. As I'm thinking through supporting students in the lab, one of the big challenges also is the extended nature of this sequence, right? It's great that we can go sort of nuts to bolts one end to the other, but our schedule is like this weird rotating 8-day schedule. We don't meet every day. So by the time I see them again, they're like, what did we do? So I always start off my class, whether it's in person or I provide these digital options to get them thinking about it as well, to help them think through, like, where are we? What step are we on? Did we complete this part? What's the next thing we need to move on? So a lot of like graphical organizers and supports around that help students who need that executive functioning support, but also helps anchor them in something. So as they're going through, they can preview this. And I'll just show you, like, if you hit next, it reminds them of other things we've done. So calling back to the manual, looking at where we are in the flow can provide just those like anchors that some students need to help remind them of where we are, right? So that they can have the confidence to build on to that next step. And then as we go through, like I'm sure many of you guys do, I provide a variety of supports, whether that's through text, video. You can see other teachers have gotten in on how to think about these molecular ideas, right? Thinking plasma membrane and all the motion that happens there to let plasmids in. And then as I'm supporting students in the lab skill part, I use these virtual simulations often as a pre-lab. So I love doing the labs in person. I love that manual skill, but our time is limited in class. And students do appreciate having some preview. So a lot of times I'll give them the option to go through these simulations that mirror the ABE labs directly. And you can choose different sort of reading levels of support here. And you can see it provides the same kind of background and context. But what's special about these is it helps them think through, okay, what am I really expecting to see? And they can make these predictions, and then they can actually manipulate all the tools. So they become familiar with, okay, what do these tools look like? How can I move things around? And it's not just a click through lab. The great part is that it really does track everything they do. So if you're using these and measuring things out, it gives you some tips about how to use the tools in a real life situation. And you can like literally pipette things and move them around. But as you get through, when you go to your results, if you don't do anything, like here it says actual results, there's nothing, because you didn't do anything. So it does help students, particularly those who are absent, who are missing school for other reasons. They can still get a sense of that scientific process and scientific skill by just playing through the lab. And for the students who do it in person, they feel a little more comfortable, a little more confident. They've seen these things before. And it's okay, they can play it as many times as they want. There's not a limit on that, and it's completely free, so anyone can use it. But they have the chance to sort of play and reflect, which I think is important to that process. And then you can see, like, in terms of molecular pieces, one of the big challenges is not everyone's talked about operons in Lab 5. I know AP definitely, that's part of the content curriculum, but for the other students, maybe it's been a long time, or you only mentioned it in passing, or maybe only they're familiar with the lac operon. So this kind of visual support with the scrollable here, like basically it's an animated activity. As you scroll, you can see things appear and move. You can kind of go back and forth to think about what you're using. I use this in class when I go over it also with the students. So you're like, okay, well, what's happening here? Can this RNA polymerase get in? Let's look at that again. Is it bouncing, or is it actively binding? So these visuals help me talk through, and it does provide the text support for students who like to read it. But I find the visuals just to be so helpful. And then my last piece here, like, it goes through another lab sim. I provide some opportunities for students to check themselves, because I find a lot of times if they go through, they can better identify their own questions. So when they come into class, we can talk about points they missed, or like I give them the chance to be like, hey, any of those questions you weren't sure why you got the answer, it took you more than a couple of times, let's go through and chat about those. Just having lots of check-ins with students really helps me get to know them and know where those pieces are that they're stuck. So that's one example of one of my digital supports here, and you can see I've added in all these like notes to students directly, and they can go through and visit these sort of at their own pace. They can look at them optionally or not. Some of them I intentionally list as optional, like the glossary here, or here's an example of one I did sort of in a hybrid way. And I had literal in-person stations before we got to the gel electrophoresis lab. So I had students like partially started online and then optionally come see me so I could work with small groups and practice those strategies with individual students more flexibly. But I know lots of people have exciting things to share, so I'm gonna pause there.
Thank you so much, Mary.
Oh, yeah.
And as many of you, as we've mentioned in the introduction, Mary is also the teacher in residence for Lab Exchange. So if you want to, maybe you could pop the Lab Exchange address, the website in the chat, Mary, and folks can contact you if they are interested in kind of learning more. And on the ABE website, we also do have some tutorials that I know you can find if you'd like to learn a little more about how to make these great personalized assets for your classroom and pathways for your classroom. So let me ask you, Dr. Cathcart, would you be willing to share an example of what you've used in your classroom? We always love these show and tell because it's real. So what have you tried in your classroom?
Let me just get these slides up here for you. Yeah, so just two things I'd like to share with you just very quickly. And these are both activities that I was referring to before that I do with my biotech crowd in TY at sort of 15, 16-year-olds, and that I was able to develop as part of the Master Teacher Fellowship Program. So the first one is, sorry, just to say, I was kind of repeating, but these are the core kind of aspects of my labs. For my TY Biotech group anyway, this is what I'm trying to, this is what I'm aiming for. This is what I feel is sort of at the core of what we're doing. So, it's more about these things than it is about biotech for me, or science even. So I suppose that again, like the great thing about the ABE activities and modules and labs is that, you know, students are able to gain all of these kind of different aspects. And so I like to focus and sort of, you know, remember and bear in mind that by doing this, we're enabling students in all kinds of ways, and we're kind of future-proofing our students, right? Because their future is unfolding so quickly, and they've got, you know, the world of healthcare alone is you know, changing at an exponential rate, and it's hard for us as you know, as biotechnologically literate teachers, as adults, to keep up with what's going on. But you know, it's our responsibility then, I think, to make sure that our students are in some way empowered and enabled to make the kind of decisions that they're going to have to make in part of their future. But at a more fundamental, I do like that they learn, that they you know, get to get a taste of what lab life is like. Like Mark said, you know, research skills, the ability to, you know, have a sort of research mindset, but also even just the fundamentals of the manual dexterity that's required, the technical ability for the things that I'm asking them to do. And I do find that it's a real equalizer. So there's kids coming into me that are academically really bright and have done really great exam scores. The grade averages are way up there. And other kids are coming in and don't really think that science might be for them. And the idea is that really it's going to suit everybody in some way. My biotech course. So those kids that don't particularly think of themselves as academic, but at the same time, they love all the you know, the sort of the technical skills that they learn, that they team up with some of these guys who've got you know, all kinds of, you know, good knowledge and understanding. They know a lot of biology coming into that, and so they team up with these guys who've got the technical sort of ability. They've got manual dexterity. They've got the ability to you know, solve problems, and so you can put together a fairly diverse bunch of kids in a team that really works. So the first activity that I get them to do this, they spend about 2 weeks doing this, and I give them some sort of free rein for a while to come up with some different possible solutions for this. The idea is that I present them with a so-called probiotic yogurt, and tell them that according to the manufacturers advertising that there are 10 billion cells in this little pot of yogurt. And do they buy that? Do they think that's even possible? So they think of various strategies. They think of even just theoretical ways, like get the volume of a bacterial cell and see if they can, you know, if it could even possibly fit in there. A lot of this they come up with themselves, right? You get them thinking about it, they'll come up with it. But then the ultimate sort of, once they're steered then in a particular way without them realizing they're being steered, they basically learn the fundamentals of biotechnology, the fundamentals of microbiology, I guess, as a prelude to doing later ABE modules. So they learn all of the basics about, you know, how to grow bacteria, how to prepare media, how to pour their own agar plates, how to isolate bacteria, how to spread plate and streak plate. They learn about serial dilutions, and they learn ultimately how to count the number of bacteria in a yogurt. So it's a kind of a 2, maybe 3 week project. And like I said, they've got the room for maneuver, the room to make mistakes, the room to realize that plan is not going to work out, and to backtrack and try another tack. So that's the first kind of activity that I do. This is last year's bunch, who had the extra level of aseptic technique because they were all wearing masks, which actually worked out quite well for reducing the contamination in their agar plates. So those are the kind of results that they get. So it's straightforward colony counting on plates. But they, like I said before, they learn so many fundamental, not just laboratory skills, but fundamentals of biology. They learn about, you know, cell division, and they learn about exponential growth. There's a lot of numeracy involved, so there's a lot of math skills that they have to sort of bring to the table. A lot of calculator work. So in that way, it's kind of cross-curricular as well. Second thing that I've done, and this was again a thing that I just developed in last year, and I hadn't done this at all before, and I've only just introduced it to my students this academic year, is again to do with you know, it's a microbiology kind of based thing, but this is at the very sort of the other end of the scale when it comes to my biotech course. So this is fairly advanced biotech for 15, 16-year-olds to be doing PCR in the school. So they're presented with a bunch of water samples. And they're told presented with a story that we have a problem in Ireland, probably more of a problem than any other European country, with certain strains of E. coli, these shigatoxin producing E. coli strains, which are associated with cattle, and we're a big cattle producing country, so we get these outbreaks every now and again. Water supplies, drinking water supplies get contaminated. So it turns out that there's two genes that are associated with these E. coli, these STEC strains. One is a shigatoxin gene. That's the one that causes the problems and can be really serious problems, especially in elderly people and young infants. So my guys know about this. It's every kind of Irish kid knows about E. coli outbreaks because they're in the news every now and again. So the other gene then is the EAA gene. This is sort of it's a virulence factor that's well known to be associated with these particular strains. So what I did was I just kind of trawled through the literature. There's various different kind of diagnostics, PCR-based diagnostics for detecting these particular strains. There's of course lots of different versions of these strains, and they keep on changing. But these two genes seem to be associated with all the known E. coli strains that cause trouble. So of course there's different versions of the genes, which adds complication to the mix. So what I had to do was I had to design not just one set of primers, but what we call degenerate primers. So they're like a mix of primers that might just be different. If you look closely, there might be just slight differences in the sequences, just maybe one or two bases different. So you have to put combinations of these primers together, and then between the two sets of primers, so it's a duplex PCR. They test their water samples. They're not actual water samples from containing E. coli. So what I do is I just spike a water sample with some genomic DNA from E. coli 0157. It's one of the sort of classic STEC E. coli strains. I just spike one of their water samples. It's a bit like one of the ABE labs, the DNA profiling lab. So samples A, B, C, D, and E. One of them has the E. coli genomic DNA in it, and then they run their PCR, and they can do it as a single PCR, they can do it as a duplex, and they end up with these two PCR products that give them a positive result. One is for the EAA gene, and the other one is for the shigatoxin gene. So yeah, I was lucky enough to be able to go last November. Just managed to squeeze into Holland to meet up with a partner that I work with an organization called Science on Stage, and with the support of Melanie there, who some of you may know from the Netherlands, from ABE Netherlands. We were able to run this pilot this PCR with a group of Dutch students, that's it. That's my show and tell for now.
So wonderful. You packed so much in such a short time, Declan. I think we could spend hours listening to you about your projects. And I'm just struck by the interdisciplinary nature of so much of what you've been describing, and how some of the skills they're learning through these experiences are applicable across disciplines, which we know the future of work is truly interdisciplinary as well. You have to bring so many of these skills to the table. And I'll stop talking because we have such a short time left, only 10 minutes left, but I'd like to invite Dr. Reyes to share a little of a project you've done with your students that demonstrates some of your approach to differentiation.
You're muted.
Thank you. Sorry. So I'm going to talk a little bit about my Master Teacher Fellowship project, which you can see on the screen here, called Viral Variants. So my vision, as I kind of mentioned before, I'm drawn to these PBL framed labs and activities. And because I was at a middle school, I didn't want to introduce the same PBL every year. So I wanted to have at least 3, one for 6, one for 7th, one for 8th. And we had the dog drill, we had the kitten paternity, and I kind of wanted one more to put in place. So to give me some variation and diversity. And you know that when it comes to, at least here in LA, there's a push towards mastery. And so what that means is that, you give students multiple opportunities to engage in the content, in order to master the content or master the skills. And so I felt having a different mystery from year to year would help me to keep reinforcing these skills that I feel is so key for high school, especially AP Bio. So these are the topics that I kind of address content-wise in the PBL version that I established. There's a QR code there for you guys. And so I'm jumping all the way down to lesson 6. And each of the lessons I kind of spell out, how many class sessions you would need. And I have only been able to do these labs virtually. So I also work with our AEA department, that's our Access, Equity, and Acceleration department, and they have a gifted network, and they put on enrichment classes. And so trying to give minority students, low socioeconomic students access to this during the pandemic was at the forefront of my mind. And so I made sure to have a virtual component as well as a hands-on component, and to acknowledge that there's an opportunity to do both, one or the other. And I believe it was Mary Lou that talked about lab exchange a little bit earlier, and lab exchange became key to my virtual aspect of my master teacher fellowship project. And so I was able to find this gel electrophoresis lab in lab exchange that mimics lab 1 pretty well. And so that was a part of what I introduced students to kind of understand the technology, the equipment involved. And I, of course, the type of teachers that we are, I had to run through it myself to find the places where students might get stuck. And then I created a simulation guide for them that would help them kind of move through that lab. And I think that's the last one that I have up, but I'm looking forward to doing this in person with students. When I did my in-person lab here at the high school, I chose to do the dog drool, but the next one and the reason I did that was because I have some of my magnet students from the middle school that are here. So I didn't want to do kitten fraternity again because they are already familiar with that. I did dog drill, and then the viral variance gives me just another option for next year in case I'm working with some of those same kids I had in middle school. They're not seeing the same lesson labs or activities again. Not that they would remember the answers, but just to, sometimes students say, oh, I've done this already, and then their eyes glaze over. So wanting to make sure that I was posing a new, framing a new problem in a PBL way for them to explore. And that is it for me. Thank you, guys.
Thank you, Dr. Reyes. And unfortunately, I'm sure many of us are familiar with the glazed eye syndrome. So I love seeing what you're doing to keep it so fresh and to keep providing those options. And technology has really been something that many of us got pushed toward because we had to. It became a necessity. And of course, Mark, you took it just that step further as you were thinking about how can technology enhance the student experience. So I'll turn you over for the last 5 minutes.
Yeah, okay. First I'd like to show you a movie. Let's see, where's my movie? I think this is my movie. Share. Here, well, the movie's not playing right now. Let's see, let's play. Yeah, there it is. Can you still hear me? Yeah. Okay, this is me. I am wearing VR glasses right now, and I cast what I see on my screen here. So you can see what I'm seeing right now. At this moment, I'm taking a tour. Oh, I press pause. At this moment, I'm doing a tour through an animal cell. This is part of my virtual reality lab. Let's see, now I'm outside the cell and I'm looking down on the cell. The lights buttons that you see, or the lines that you see, is those are my controllers. So I can select things. So now I'm almost at the front of the cell. The cell it's a pretty simple cell. I couldn't find a better one. It's just, I tried to look for all kinds of 3D models on the internet. You can see the nucleus over here. And when we come closer later on in the movie, but I'm not going to show that because it will take too long. I stop share for a moment because it's distracting me as well. When you come closer, you can look inside the cell, you see the nucleus, and I also added some DNA inside the nucleus. While you are in your VR environment, some questions pop up and you have to answer them. Well, I make my answers in that way that you can't answer them wrong, because I want the kids to continue, not to get stuck somewhere. And because everything is just a prototype, it's just some, well, my programming skills are not extremely well, so they get stuck anyway. So I don't want to get them stuck on the questions. That is one part of the program that I made, because when I got this stipendium from ABE, I was thinking what I wanted to do. And here in the Netherlands, we have, well, in schools, we have not much time for our kids. I want to do some extra things. I want to do some practicals. I want to show them things, how it works, especially when it comes to DNA or molecular things. But I don't have the time for that, because we need to go until a certain goal, and they need to do a central exam, and we just don't have the time. So I wanted to give them, I wanted to make something that you can easily grab. A lab you have to prepare, it's a lot of time, and well, I can pick up my VR glasses and give them to students that are interested in my lab. Right now I have 5 VR glasses at school, so I can do more at once, and they are all doing something different. First of all, they have to look for some DNA samples, and then they are going to isolate the DNA. The VR tour through the cell is just, well, it's the most not realistic part of my lab. And now I'm going to show you a more realistic part, or not realistic, but the other half of my lab. Oh, I need to share my screen, not just look at it myself. I have it here, share. This one. This is, you can also look at your lab not through the VR glasses, and this is how it looks like when you look in 2D. When I press away, it's the cross, it's going to run, because I just paused it. This is a guy called Gregory, and he wants you to do some experiments, and a PCR is running at the moment, and we're ready to start an electrophoresis. And now he tells us the buffers are over there, and there is something. He asked me a question about a loading buffer. Why? Because we just watched a movie about electrophoresis, how everything works. So I have to answer a question for loading buffer. There is sound, but I just turned it off. Well, to make everything more clear, I added some pictures. And right now, just wait a minute, and then, well, I know it. Well, I hope you hear it as well. My PCR is ready. Oh, there's the sound. He's really happy that my PCR is. I hope I can I turn down the sound a little bit? Because it's really loud. Well, my sound is softer now. He's really happy now, and he wants me to do some, well, to put my PCR, to click on my PCR machine. See, there's a little hand popping up. I click on it, and my PCR machine opens, and there are my samples. And now I have to pick up my P20 pipettes, and well, I have to load them on gel. So I click on my P20. It's this one, and okay, it is already mentioned in a lab before. You need to put a tip on your pipette each time, and there's my pipette, and I remembered the tip. So now I need to load my gel. You get instructions here. And also Gregory is also helping me and telling me what to do. So I have to take out 18 microliter of the first test tube. So now I can, when he stops talking, I can select my test tubes. And then I selected it, and now I have to put in the loading buffer. Oh, I need to put them in new tubes, of course, yes. And on this one, and now I have to put in the loading buffer. I have to wait until, oh, I forget something. A new tip, of course, yes. And then I press the loading buffer, and then I put it, I need to put it on gel, I think.
Mark, I'm noticing we're at time, and I feel so sad because I'm enjoying watching. This is so great. This is just wonderful, and this is why we loved saving you here so that everyone could get excited by these great products. I just want to say a huge thank you. I know we went a little bit over time today, but first of all, thank you to all of our panelists for sharing this incredible stuff, for sharing your projects, for sharing the materials you've developed. For all of you who registered for today's roundtable, we will share our participant materials. So we'll share these great slides and examples from our panelists so that you can look at them at your leisure. And we will also be posting the recording on our website. So if you missed any part of it, or if you want to share it with a colleague or a friend, please feel free to share the link with anyone that you would like, and it will be available as a resource after today. Hopefully we'll have it up within a couple of weeks, and you will be able to look at it anytime you want. So again, huge thank you to all of our panelists for being with us today. And we also appreciate all of the folks from the program office, from the Amgen Foundation, and particularly the teachers who have joined us today. We're so happy to have you with us. So thank you for sharing your expertise, for giving your realistic viewpoint of what you can do in this classroom, and thank you for being part of ABE. And thanks to everybody who joined us today. Have a great rest of your day.